Hello students, today we'll be talking about spline interpolation. It is another kind of a interpolation. Unlike the polynomial interpolation, where there is only one polynomial connecting the given points, in the spline interpolation, the function to be used in interpolation is piecewise. That means there is a separate polynomial function for every two consecutive given points. The points at which the two connecting splines meet are called knots or nodes. What is a spline function or a spline interpolant? A spline function is a function that consists of a polynomial piecewise joined together with certain smoothness conditions. So let us see what are these conditions. Suppose that f0, f1, f2 up till fn are discrete values of a function fx at n plus 1 nodes, that is x0, x1, x2 up till xn respectively, where we have a condition that they are in the ascending order. So A and B, which is x0 and xn, are called the external nodes, and the internal nodes are x1, x2 up till xn minus 1. A spline of degree k is a function Sx satisfying the following condition. So S of x passes through the points xi, comma f of I, that is S of xi is equal to f of xi for I going from 0, 1, 2 up till n. On each subinterval, the Sx is a polynomial of degree k. S of x and its first k minus 1th derivatives are continuous on the open interval x0, xn. Suppose that the spline S of x is made up of the polynomials s1, s2, s3 up till sn. So in the subintervals x0 to x1, x1 to x2 respectively, then we define the spline interpolation as this, where all these polynomials are known as spline functions or spline interpolants. So when k is equal to 1, we have the linear spline interpolation. So let us talk about linear spline interpolation. It is a function that consists of a linear polynomial which is piecewise joined together with certain smoothness condition. The definition remains the same, but the only difference is that on each subinterval we are having a polynomial of degree 1, that is a linear polynomial, and the third point that the spline function is continuous on the whole interval. So here we are not talking about any derivatives of the function. So how to find the linear polynomials? Here we have a formula. Six is equal to yi minus 1 plus the slope of the 2 points multiplied by x minus xi minus 1. You can calculate all the splines starting from 1 up till n. So this is a graph which represents the linear interpolation. So we have a data set. You could easily see that for every two consecutive data points, we are having a separate spline function. That is, for these two, we are having S1x. For the next two, we are having S2x and so on. The 0 point and the last one, that is 13, they are known as the external nodes, and moreover the internal one, that is from 1 up till 12, are known as the internal nodes or knots. You have to note one thing here, that if the data is given in a jumbled form, then we have to rearrange them either in ascending or descending order. So it is preferred that we arrange them in the ascending order. So let us see one question related to a linear spline interpolation. Compute linear spline which interpolates f at the knots 0, 1, 2, where the function is x cube. So here you will see that I have created a table of x and y. So where x is 0, 1, 2, correspondingly my y, that is f of x, is x cube, which is given by 0, 1 and 8 respectively. Now what we have to find? We have to find out the linear spline function. So Sx would be equal to S1x and S2x, as we are having 3 points. So always remember the spline function would be one less. That means we'll be having two spline functions in this. So from 0 to 1 is the first spline function, that is S1x, and from 1 to 2 we have another spline function, that is S2x. Now we'll be substituting I is equal to 1 in this formula to find out the first spline function. The data is given above. आपके पास y0 y1 y2 and x0 x1 x2 अवेलेबल है. आपने सिर्फ इस फॉर्मूले में सब्सटीट्यूट करना है और आपको वैल्यूज मिल जाएंगी. S1x is x, and on the similar basis I have calculated S2 of x, that is 7x minus 6. So this is my spline function for the given data set that was given to us. So please see how I have written this. This is the format to write a spline function. For x belonging to 0, 1, that is x is lying between 0 to 1. So आपका जो S1x है, that is x, and S2x is 7x minus 6. Let us consider one more question in this. Find the value of velocity at 16 seconds using the linear spline interpolation for the following data. The data is available to you, but there is something missing here. Please note that the time, that is x in this case, and velocity, that is y. So generally we have x and y, we take the formulas and everything is x and y, but here it is time, so I will consider it as t, and velocity I'll consider it as v. So time is not written in the ascending order: 0, 10, 20, 15 and then 22.5. So what would be our first step? सबसे पहले हम इसमें इसको रीअरेंज करेंगे असेंडिंग ऑर्डर में. आप डिसेंडिंग ऑर्डर में भी कर सकते हैं, बट आई ऑलवेज प्रेफर टू राइट इट इन द असेंडिंग ऑर्डर. सो आई हैव क्रिएटेड अनदर टेबल जिसमें टाइम जो है मैंने लिखे हैं असेंडिंग ऑर्डर में 0, 10, 15, 20, 22.5. कॉरस्पॉन्डिंगली वेलोसिटी मैंने लिखी है नीचे as v0, v1, v2, v3 and v4. So let me write this as v4. Yes. So आपको क्या फाइंड आउट करना है? Here we have to find out v at 16. तो आपको पूरे spline functions फाइंड आउट करने की जरूरत नहीं है. क्या हमने नोटिस करना है कि आपका जो 16 है, v at 16 मतलब आपका t 16 है, इसके बीच में लाई कर रहा है. इट इज लाइंग बिटवीन t2 एंड t3. सो हमें सिर्फ जो 15 और 20 जो टाइम इंटरवल है आपके पास, उसी का स्प्लाइन फंक्शन आपने फाइंड आउट करना है. यहाँ पे कितने पॉइंट्स हैं? यहाँ पे आपके पास 5 पॉइंट्स अवेलेबल हैं, तो आपके पास ऑटोमेटिकली 4 स्प्लाइन फंक्शंस मिलेंगे. तो यहाँ पे आपको 4 के 4 स्प्लाइन फंक्शंस फाइंड आउट करने की जरूरत नहीं है. अगर क्वेश्चन में आपको गिवन है कि फर्स्ट फाइंड द स्प्लाइन फंक्शन एंड देन फाइंड द वैल्यू ऑफ वेलोसिटी एट 16, देन यू हैव टू फाइंड आउट ऑल द 4 स्प्लाइन फंक्शंस. मगर यहाँ पे हमें सिर्फ पूछा गया है फाइंड द वेलोसिटी एट 16 सेकेंड्स. So I'll be just finding out the spline function for that particular interval only. So consider T2 as 15, T3 as 20, correspondingly their V2 and V3. Now the spline function in this is given by the formula Vt is equal to V2 plus V3 minus V2 upon T3 minus T2 times T minus T2. If this is confusing, आप इसको y की फॉर्म में भी लिख सकते हैं. That is totally your choice. So when I have calculated at t is equal to 16, तो यहाँ पे राइट हैंड साइड में जहाँ भी t अवेलेबल है आपको वहाँ पे 16 पुट करनी है वैल्यू, और जब हम कैलकुलेट करेंगे आई एम गेटिंग इट एज 393.694 मीटर्स पर सेकेंड. सो एज यहाँ पे जितनी भी वेलोसिटी है वो 2 डेसिमल प्लेसेस में है, सो आई हैव जस्ट राउंडेड इट ऑफ and I am writing the velocity at 16 as 393.70 meters per second. So this is the first lecture of linear spline interpolation. In the next video, I'll be talking about some more questions of linear spline interpolation, and then we have quadratic and cubic in the series. Thank you so much.